Well, hello, welcome back to my stream on solving Advent of Code. Um, well, today is the day that Cyberpunk 2077 is coming out. Uh, I guess here in New Zealand, yeah, we're a day ahead, so maybe it's not out yet, actually. I'm not sure anymore. It should be out, right? I'm not sure. Anyway, so that's something to look forward to. I don't know why I talked about that. Um, yeah, so a couple of things about the challenges. I think over the last couple of challenges, for one or two of them, I guess this is a bit of an apology. I kind of said like, oh, these challenges are a bit like boring or straightforward, or I can't remember exactly what words I used. But yeah, no, I just wanted to apologize to the creators of Advent of Code for that sort of for saying that sort of thing, because I know how much work it goes into planning this, creating this, and it's not easy to come up with 25 different problems that are challenging and fun and uh, give people a sense of progression. They get harder and harder every day overall, and so yeah, no, huge props to the creator and the whole team that goes into testing and maintaining and making this whole thing work, because this is something I look forward to every day. And even if the challenges are quite straightforward, maybe it's straightforward for me, but not for other people. So huge shout out to those guys for putting this together. What else? Yeah, well, yesterday we didn't get to go over the CPU stuff again, and I'm not anticipating we do it again today, but I've set it up just in case to give us that little bit of extra edge. Oh, right, that's the other thing. So over the last couple of like the last 9 days, I've kind of tried, like, made it a kind of a goal to be doing this as quickly as possible to try and get those points by placing in the top 100. But I've realized, just thinking about it, that that doesn't make for a very entertaining or informative stream, because I'm just kind of, all you end up doing is watching me kind of silently type away at my computer. And so I've decided I'm gonna not make trying to get into the top 100 for each problem a primary goal anymore for me doing this stream this year. For me doing Advent of Code this year. But I will try to read the problem out, make it clear what's going on, and try to explain my thought process better as I keep going, as I'm solving it, why I'm doing a certain thing. But I probably will have to, like, as I do that, I will probably change the level at which I explain things a little bit. So I probably won't go into the details of explaining exactly how programming in JavaScript works. I will have to assume a certain level of programming knowledge there, but if there's anything interesting that comes up, then I will definitely talk about it, or try to talk about it, because I don't have a good track record of that so far anyway. Yeah, so 1.5 minutes to go. One thing I'd been thinking about doing was updating the CPU code to not have this main loop in my in my kind of daily code file, but to kind of do some sort of like exec function where you have like a generator for inputs and a function for outputs. Because eventually, I'm pretty sure this thing is going to need, or at least I'm guessing, this thing is going to take in user inputs or output things, and then we can draw things on the screen. And like last year we were playing Breakout, and we had to give it inputs as in left or right to move the paddle to hit the ball, and things like that. So we need something like that in here. Input will probably be a generator, so that we can keep feeding it new new inputs, and output will be a func, so that we can take each output and kind of draw it on the screen or do something with it. But yeah, if that comes up today, we'll just have to implement it on the fly. But if it doesn't, maybe I will do that beforehand. Right, and the problem is up, so let's go. I'm gonna get the input first. Cool. Let's read what's going on here. That's a lot of inputs, a lot of numbers. So, yes, so yesterday we found a port on the seat in front of us or something like that. And when we plugged it in, we found that it's outputting a whole lot of numbers, which we were trying to kind of figure out what they were. So once we patch it in, we discover weather forecasts for a massive tropical storm. But before we can figure out how it will impact our vacation plans, my device turns off. My battery is dead. I'll need to plug it in. But there's one problem. The charging outlet produces the wrong number of jolts. Jolts, not volts. So I make a list of, so always prepared, I make a list of all the joltage adapters in my bag. Each joltage adapter is rated for specific output joltage, my puzzle input. So I have, I have 100 adapters in my bag. Any adapter can take an input 1, 2, or 3 jolts lower than its rating and still produce its output joltage. Okay, 1, 2, or 3 lower than the rating. So if it says 38, then I can take 35, 6, 7, or 38 jolts. In addition, my device has a built-in joltage adapter rated for 3 jolts higher than the highest rated adapter in my bag. Right, my device has a built-in adapter for 3 joltages higher than the highest rated adapter in my bag. So I guess the first thing we need to do is figure out what my highest adapter is. One way to do that is to do a reduce. And we say, so A is accumulator. So when in a reduce, you're going over every value in your list, and you are performing an option on that with the accumulated value, which I've called A and N for next. So I'm saying if N is greater than A, then we return N, otherwise we return A. So we're always returning the greater one, and we're starting with 0, right? That should be the right way around. Ooh. So my highest rated one is 154. Cool. So my handheld, my device is 157 then? 3 jolts higher than the highest rated? Yeah. I guess I could make that programmatic. Treat the charging outlet near my seat as having an effective joltage rating of 0. I could do math.max? Yeah, I could do math.max. I didn't. Let me give that a go. Do I need to do like this? Yes, okay. Cool. Yeah, spread operators are amazing, and we should probably use more of those. Yeah, nice. Thanks, Blue Ghost. Since I have time to kill, you might as well test all my adapters. I wouldn't want to get your result and realize I can't charge my device. If you use every adapter in your bag at once, what is the distribution of joltage differences between charging? That's a weird question. For example, suppose that in your bag you have adapters with the following joltage ratings. With these adapters, my device's built-in joltage adapter rated 19 plus 3, yep. Because adapters can only connect to a source 1 to 3 joltages lower than its rating. In order to use every adapter, you need to choose them like this. So I need some, yeah, start with 1. From 1 I can go to 4, from 4... Oh, right, okay, so you kind of need to daisy chain them up, one at a time. In this example, when using every adapter, there are 7 differences of 1 jolt and 5 differences of 3 jolts. Here's a larger example. Okay, what is the number of 1 jolt differences multiplied by the number of 3 jolt differences? So I guess we could just sort it, right? Now when sorting numbers, when the default array sort in JavaScript, last time I checked, and I could be wrong, but last time I checked, it sorts by Unicode point values. And so to sort by numeric values, we actually do need to give it a custom sort function. Yeah. And so that will give us the sorted thing. So I just need to check the differences between them, right? Between every set of numbers. So I don't know, for let I equals 1, I less than input.length. We'll just do a little thing like this. Yes, this is horrible. I'm sorry. I'm really sorry. Let's go with I++. So we want input I minus input I minus 1. And then we can go diffs diff plus plus. Cool. So what is the difference between one jolt differences multiplied by 3 jolt differences? Let's just do it in here so you can see what's going on. 1890. Curiously, it's the right answer for someone else. You might be logged into the wrong account or just unlucky. If that's the case, I need... Okay, maybe I did it wrong. I don't think I'm logged into someone else's account. Does it not return a new array? Or does it? No, I thought no. It's in place, right? Sort is in place. That's why over here when I go console.log input, I get it's sorted, right? Input.sort is in place. Is it not? Yeah. I guess if I add up all these differences, right? I should get that's 93. So adding that up is 93. So is input.length 94? It is. I can't be logged into someone else's account. I haven't touched this at all. Yeah, it's still my account. Okay, I mean, we can test it with like the smaller input and see what we get, right? Six and 4. There are 7 differences of 1 and 5 differences of 3. Ah! I forgot to check 0 and I forgot to check the last one. That's what I missed. I have to all right, I'm gonna do something kind of a little sketchy here. Just go sorted equals. Can I do this? I can go 0 ... that and then max. I think I can do that, right? And then we want to go to, yeah, I'm not sure where that nan comes from. Where does that nan come from? Ah, wait. I mean, that's the general idea of what we want to do here anyway. Maybe I can go sorted dot push max. Oh, target is what I wanted, not max. Zero dot that target, not max. That's what I wanted. 7 and 5. 7 and 5. All right. And since we're doing this anyway, we may as well check the other numbers. And this one should be 22 and 10. 22 and 10. Cool. All right. So that's some reading. So yeah, so I missed out. I forgot to put in 0 and 100, which was the start and the end of, which was the beginning and the target. So that was me not reading the question properly again. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. I've noticed that there's no difference of 2 in here. You'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect the charging outlet to your device. Previous rules still thing. Yeah. So it's kind of like how many of them we can take out, right? Oh. Yeah, sure. Okay, so yeah, so this is basically saying, because some of these differences are 1, right, and some of them are 3, but the voltage adapters, they work even if they are 3 apart. You know, if we had a 1, 4, 5, 7, we can go straight from 1, 4 to 7. We don't have to have the 5 in there. And so the question is asking how many different ways we have of connecting these up. But yeah, it's right. There must be more than a trillion valid ways to arrange them, right, given how many adapters we have. So there must be a more efficient way to do this. So let's think about it. So here's an interesting thing, right? With all of these questions, there haven't been any 2 adapters that are 2 apart. They've always been either 1 apart or 3 apart. So I think we can do something with that. Let's go with sorted and see what we get. Right, we can go 2. So if it's 3 apart, you have to keep both. But if it's 1 apart, you can probably take out. Yeah, you can take it out if it's 1 apart. Now, what's the efficient way to do this? Right. If the difference between any 2 of them is 3 apart, you have to keep them so that you can't remove them at all. They have to be there. Right. So in this case, 2 and 5 are fixed. They have to be there. 0 is also fixed, and 157 is also fixed because we have to have them. I'm wondering if I need 0 and 157 in this, though. I feel like I need it to validate. Yeah, okay. So doesn't that just mean that every... See, this 8 is interesting, right? This 8 is interesting. I feel like in this example, right, this is all the numbers. You have, so 1 is fixed because 4 is there. 1 and 4 are fixed, right? 7 and 10 are fixed. 12 and 15 are fixed. And 16 and 19 are fixed. So that leaves 3. And each one can be on or off. So it's 3 to the power of 2. Right? This is 3 to the power of 2. But that doesn't make sense because this is 19,208, and that's not a power of 2. Oh, no, it's 3 to the power of 2 of 2. No, it's 2 to the power of 3. 2 to the power of 3. So in this case, I feel like it's something along these lines, right? These are fixed. There's some weird thing going on here with the start and the end, right? These are fixed. These are fixed. These are all fixed. These 2 are fixed. These 2 are fixed. This one's fixed. These ones are fixed. These 2 are fixed. This is fixed. Cool, and this one is fixed because it goes to the 52. And so by the logic we worked out for the first one, right, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to the power of 2. No, 2 to the power of 15, which would be 16, 384, I think. 1024 is 0. 1, 2048, 2048, 4096, 8192, 1684, 32768. 32768. So that should be 332768, but it's not. It's 19208. 19208. And it's something to do with, it has to be something to do with like this long stretch here of like, let's say the 7, 8, 9, 10, 11. Maybe that's the way to look at this. Instead of looking at the ones that have 3, we look at them in groups of contiguous like sequences. Like this. Maybe it's because there are 3 contiguous sequences, not including the first and the last one. And so that's why it's 3 to the power of 2. Any one of these sequences can have 1 missing. No, that's not true. That doesn't make sense. This could have 2 missing. This could... And we already checked that 19208 isn't a... isn't a power of 2 anyway. What is 19208? It doesn't divide by 3. It divides by 7. 19208 divides by 7. It's 7 to the 3 plus 2 to the 3. Times 2 to the 3. Right? That's such a weird number. Times 2? No, times 7? Oh, these are the puzzles I like, but I feel like I'm taking so much time. Sorry, guys. I have no idea how to do this. See, this is interesting, this stretch here. Let's look at the stretch. Because we can take out, it must be some kind of combination thing here, right? We can take out just the 8, we can take out just the 9, we can take out just the 10. We can also take out 8, 9, and 9, 10, and 8, 10. So we can take out 6, so there's 6 different arrangements for this little sequence here. But how can they be, no, but wait. 7, no, there's 7 arrangements for the sequence here because you can also take nothing out. Ah, that's where the 7 comes from. That's where the 7 comes from. So then maybe this is the way to look at it. Here, you can take out the 5, or you can take out the 6, or you can take out the 5 and the 6. So that's 3. Then here you can either take out the 1 or you can keep the 1, 11. So that's 2. I feel like there's more. You can keep both the 5 and the 6. Ah, you can keep both the 5 and the 6. Or you can take out either one of them, or you can take out both of them. Yeah. So that's why it's 4. Here, when there's a sequence of 3, you can either keep it or take it out. So that's why it's 2, and that's why it's 2 times 4, which is 8. Here we have a sequence 0, 1, 2, 3, 4. So we can either take out, so this is 7, this is another 7, this is 4, this is 2, 31 to 35, this is 7, see, this is 0, 0, 1, 4, 7. What's the what's the sequence here? And that's 7. So that's why it's 7 times 7 times 7 times 4 times 2 times 7. 7 times 7 times 7 times 4 times 2 times 7. That's how we get it. Yes. Okay, we found it. We found it. So now we just need, now I just want to like kind of, so the sequence we have is 0, 1, 4, 7. And I wonder what it is for the last for the next one. So say we have 1, 2, 3, 4, 5, 6. What can we take out in this sequence? We can take out 2, 3, 4, 5, 2, 3, 4, 5. So that's 4. Yeah, I'm going to run out of space to type stuff. So that's 4. We can take out 2, 3, 4, or 5. That's 4. We can take out 2 and 3, or we can take out 3 and 4, or we can take out 4 and 5, which is 3. We can take out 2 and 4, or 3 and 5. That's another 2. We can take out 2 and 5. That's 1. We can also take out 1, 2, 3, 4, 5, 6. So that's 6, right? 4 plus 6. This is like some kind of Pascal's triangle thing, I think. We can take out 3 numbers. Can we take out 3 numbers? No, you can't take out 3 numbers in a row. So is that just 10? Oh, I wanna like play with some physical thing just to see what's going on. I'm just trying to figure out if there's like another set of, can I take out 4 numbers? I can take out 3 numbers. Hang on, I can take out 3 numbers. I can't take out 2, 3, 4, but I can take out 2, 3, 5, and I can take out 2, 4, 5. So that's another 2. So we're up to 12 now. Maybe this thing we can do programmatically. Just to make sure we're not missing anything. What is the sequence of numbers that we can remove from a thing to make sure that we don't never have any difference greater than 3? So if I have 3 numbers, does this work in JavaScript? Oh, it does. Powers work in JavaScript. Well, that's kind of neat. Okay, let's just give this a little go. See what we get. We're gonna go 1, 2, 3, 4. That. Yeah, 1, 2, 3, 4 like that. We're gonna go for let I equals 0, I less than 2 to the power of a dot length, I plus plus. So we're just gonna what I'm gonna do is I'm gonna toggle on and off each of these. This is this is a brute force way to do this, but I'm going to toggle on each number. So I'm going to say const b equals, we copy a, so we can't toggle the first and the last numbers, and so this is actually only to this minus 2. Yeah, so I'm going to generate every combination of toggles for the stuff. I'm going to say for equals 1, j less than a dot b dot length minus 2. Yeah. No, I'm going to go 0. Yeah, 0, 1. This is 4, yeah. Okay, so I'm going to say if j and, no, if, what is it? How do I do this? If I shifted by j and 1 is off, then we delete it. How do I delete it? That doesn't work because I have to go backwards. Oh, this is too hard. This is too hard. No, I can. I can just set it to 0. I can just set it to 0. We'll have to do an extra pass. Can you even delete stuff from arrays? I want to just do it the other way around. All right. Yeah. But like, it's gonna mess up with my indexes if I delete stuff. Oh, I want C here. Oh, I gotta put brackets around this. 1, 2, 1, 2, 3, 1, 2, 4, 1, 2, 3, 4. I'm toggling 3 and 4, which isn't what I want. There should be +1. That's giving me all the stuff. Yeah, okay. So now I have all the combinations, right? And I just want to count how many of these combinations are valid. So is valid array is going to be, we're going to just copy this diff code here because, no, we don't have to. We can copy this diff code. Plus if r that minus r that is what, greater than 3? Greater than 3. Yep. Then we return false. Otherwise, we've checked everything. We return true. Cool. So with this, I should get 1, right? With this sequence, I should get 0. If is valid C count plus plus. There you go. I get 1. Yeah, okay, I get 1. Sure, 1 makes sense. With this, I should get 2 then. There are 2 valid sequences. Yep. With this, I should get 4. With this, I get 7 though, right? Yeah, I get 7, not 8, 7. With this, I get 13, not 16, 13. Okay, so let's just build this up. What is this looking like? 3 is 1, 4 is 2, 5. If this is close to powers of 2, but there's some weird trickery going on because of the gap of 3, right? Oops. So with 8, we should get what? I'm gonna make a prediction here. 16, 32 minus, it's gonna be 32 minus, I'm gonna go with minus, it's either minus 6 or minus 4. I'm gonna go with minus 6. So I'm gonna predict 26. Let's see what we get. Oh, 24. That's minus, how much is that? Minus 8. Oh, minus 8. Okay, so this is 8 minus 1. This is 16 minus 2. This is 32 minus 8. That's... Wait, I got these wrong. This is 2. What is the pattern here? Oh, I got it wrong. My bad. It's minus 3. 1, 3, 8, 20. Yeah, I don't know what the pattern is, so I'm just gonna... What is this? 81, which is 128 minus 47. Okay. So what we're going to do here is we're going to just brute force this. Const A equals this. For a, we'll do like sequences from 1 to 20 or something. 1 to 20. For I'm going to run out of numbers. Equals 1, L less than or equal to K, L plus plus, A dot push L. So that builds our array. Going to do that. We're not going to log that out anymore. And then we're going to build up A. Const comms, combination comms, combins. Do that, and then we're gonna go combins K equals count. I'm gonna print out combins and see what we get. Okay, so that should be enough, right? For our program. And we'll just chuck this as an initiation thing at the top. Oh, we'll chuck it here. So there we go, we got that. Oh, I need this is valid function somewhere up here as well, don't I? So now we need to identify all the contiguous sequences. But that's easy, right? We can just break up the sorted input. Const groups equals this for let I equals 0, I less than sorted dot length, I plus plus. So we're just going to go through the whole thing, and then every time we come across every time we come across a gap of 3 or more, we're going to split it. Yeah, every time we come up with a gap of 3 or more, we're going to split it. We can probably use some splice thing in here. Yeah, so we'll go like, we'll give this better names. Start. For let end equals start plus, no, equals start plus 1. Yep. Less than sorted dot length end plus plus. If sorted end minus sorted start is greater than 1, that means we need to split it. And if we're splitting it, this is where we need to use splice. let's do this so I can have something to actually think. So what are we going to get to? We're going to get to start as 0 and end as 3, right? Oh, it's not n minus start, it's minus n minus 1. Whew, that was close. So sorted end 0, 1, 2, 3, right? It's going to be 3 minus sorted 2. N is going to be 3. Oops. Yeah, so that's greater than 1. And so therefore we need a.splice start, which is 0 and 3. And is there a second argument in splice the length or the wait, what happened to my A? I thought splice gives me a new array. It doesn't affect the old array, does it? Oh, it deletes elements from the old array? That's not the behavior I was expecting. But that actually makes things easier, right? It's a completely different loop. It's not what I was expecting. in the end, split. Really? Oh, that's so weird. All right. Okay, we'll do it that way. We can do it that way. We can do it that way. While sorted dot length greater than 0. That's going to destroy my array though. But that's okay. A.splice 0, 3. And A is now that. A.splice 0, 3 again. And A is 0. So while the length is greater than 0. While the length is greater than 0, if sorted dot length, this is the end condition, length equals 1, then we go groups dot push sorted break. That's just the ending condition because we won't be able to compare beyond the end of the array. Otherwise, if sorted, we can go, I guess, let I equals 0 for I less than sorted dot length I plus plus if equals 1, right? If sorted I minus sorted I minus 1 is greater than 1, then we break. We'll do it out here. We'll do it out here. Groups dot push sorted dot splice 0i, and we keep going. That seems to be good, and we only needed sequences of up to 5 in the end. Maybe I should have started with that. Sequences of up to 5, didn't we already know sequences up to 5 is just 7? So we didn't even have to... So we knew, I think my computer lagged for a bit. We already knew that sequences of 5 is 7. So we didn't even have to do all this work up here that we did to kind of create this array. Because we just had all the information anyway. We didn't need that much information. Oh, we did all this work for nothing. Okay. And so what we have to do is, actually just make this dot length. Cool. Cool. And we map it. Dot map into sorted to combines in, and we multiply them all together. All right, is there a quick way to multiply numbers together, or do I have to reduce this time? That looks really big, and I'm not sure that is 2 times 7 times 7. I'm just checking on a calculator. I don't think you can see it on my screen. Feels about right though. Oh, I got it right. Okay. Oh, I did a lot of work for nothing. If only. Oh, so what I could have done, right? I could have just checked my input first, and if I had known that the input was just 5 numbers, like if there were no contiguous sequences longer than 5, I didn't have to do all that work to figure out what it was that of like what it was, right? Like what. So it took ages for me to come up with the logic for how to work out how many different combinations there possibly were, right? And yeah, so I started off with the gaps, right? Like the gap of 3, noticing that there were always either gaps of 1 or 3, and so it was just sequences of contiguous. It was just contiguous sequences split by things with a gap of 3. And then it was figuring out from not looking at the gaps, number of gaps, but looking at the number of ways you could arrange things within the contiguous sequences that were between the gaps. Like this. And if only I just checked my input first, right? That I didn't have sequences longer than 5, then we already had the logic, right? 5 is 7. A sequence of 5 has 7 combinations. A sequence of 4 has 4 combinations. A sequence of 3 has 2 combinations. And then lower than that, you only have 1. And then it was a matter of just multiplying all that together. So yeah, this was a really tedious. I use that word in a good way, right? Like it was a really long. It was a. Okay. So honestly, I really enjoyed this, right? Because I enjoyed the fact that I was stumped by how hard by the logic for the question and figuring out how to optimize it. And I really enjoyed having to figure that out and figuring it out. It feels really good. Yeah, I wonder how I placed this today. This is a really neat challenge, I think, and it really makes you think. Maybe there's something about combinatorics that I should have remembered from uni. 2000? Yeah. No, I'm happy with that. Cool. So thanks for joining me for today. Thanks, Blue Ghost, for your JavaScript pointers. It's always helpful. Really appreciate that. Cool. And it's getting late, so I will see you tomorrow. Thanks for joining. So thanks for joining me for today. Thanks, Blue Ghost, for your JavaScript pointers. It's